Okay, let's give you guys some more practice. So find the volume underneath this surface, in this specified region. So when you look at this specified region, the origin, this is your x-axis, this is your y-axis. The origin is somewhere around here. So x equals 1 to infinity. So let's say 1 is here, 2 is here, 3 is here. X equals 1. From x equals 1 to infinity, it means this. Hang on. So 1, and then y equals 1 is here. So it's really talking about within this region here, all the way to infinity. So it's everything beyond 1 and 1. So 1. Let's just say 1 is here. 1 is here. So it's everything in this region all the way to infinity. Well, work out this volume here underneath this surface. So press pause and have a go. Okay, so to do this, imagine, well, if look at the inner integral. Looking at the inner integral, you're integrating it with respect to x first. So this is a constant. So imagine it as one block multiplying another block, and this block here is a constant. Well, if it's a constant, because we're integrating with respect to x, if it's a constant, you can take it out of the integral. So it looks like this. So it looks like this. And then now we can easily integrate this. So when you integrate this, it's going to be natural log of x from x equals 1 to x equals infinity. So now we need to put this big, really big number into here, and then take away 1. Well, put 1 into this thing here. That will then give you this. Take away this. Well, natural log of 1 is 0. So that becomes this. That becomes this. So now this thing here doesn't really make sense here, but just imagine this block here as being a very big number. Just bear this in mind. It's going to be a very big number over y. So now just imagine this as being a very big number. So we can take it out here because it's in effect a constant, because we're integrating it with respect to y. So it's going to be a very big number block here, and then you've got your normal standard integral inside here, and then now just integrate it. So integrate this. It will give you natural log of y. Now put infinity into here. So that will then give you this, and then put hang on, I made a mistake. Put 1. Hang on, and then put 1 into here. That would be natural log of 1. Natural log of 1 is 0, so it will then give you this. So what that means is the volume is given by a really big number times another really big number. So what that means is that the volume gets bigger and bigger. The volume diverges. Okay, so you can't really calculate the volume. The volume just gets bigger and bigger. So when you're trying to find the volume underneath this surface, you can't, because the volume just gets bigger and bigger. Okay, so yeah, so the volume diverges.